Hi, my name's Chris Scott and I'm here with Ernst Ruhl from Geisenheim. How are you, Ernst?
Pretty good.
Excellent. Can I call you Ernst or Professor Ernst?
No, that's quite okay to call me Ernst.
That's all right. Brilliant. You're a professor here. And what's your role at Geisenheim?
I'm the head of the Department of Grapevine Breeding and Grafting.
What does that mean?
That means that we are breeding rootstocks. We are also developing clones, and we're evaluating disease-tolerant varieties. The department in the past also was involved in the development of grafting methods. That's why the name still includes grapevine grafting.
Oh, okay, but you don't do that anymore?
Well, the industry basically developed, so they don't really need us to tell them how to do it.
Okay, I thought everybody just used that Omega graft.
Yeah, that's what they do. They use Omega grafts, and well, most of the nurseries here are they produce between 500,000 and 1 million vines a year, so they know what they're doing, otherwise they wouldn't survive.
Brilliant. Oh, just for the listeners, Omega graft,
it's basically a 1-year-old wooden cane from the sign and a 1-year-old wooden cane from the rootstock, and basically you punch an Omega-shaped cut out of both of them, and they fit snugly together and actually stay together, so you don't have to fix them with wax or with budding tape or anything like that.
Was it quite hard before that was developed?
Well, there were other methods around, but most of those involved some, technical know-how.
Yeah.
While with an Omega cut, that's so easy.
Anybody can do it?
Yeah.
Okay, and you get a machine, so it's all...
Yeah, you have a machine and, skilled crafters possibly doing 10,000 a day.
What we're going to talk about today is we're actually going to talk about Phylloxera. But just before we get into that, how long have you been at Geisenheim?
I started here pretty much 20 years ago. Mm. And before that, I was working for 6 years in Australia for the federal government.
Okay. You don't have an Aussie twang.
Sorry about that.
No. I wouldn't be sorry about that. You know, nice Sydney side accent's lovely, but we've just done a wee tour of the vineyards, and you showed me some leaves that were quite heavily gall. That's the right word, isn't it? Yeah. It's wee lumps on the leaf.
Yeah.
I see it on my apple tree at home a wee bit.
Yeah, here it's a different animal that caused that. The animal that caused those galls is Phylloxera. Mm-hmm. Phylloxera is an aphid, and like all aphids, it usually feeds on leaves.
Oh, okay.
The interesting thing with Phylloxera is that Phylloxera can only actually feed on grapevines, and the vine we've seen out there is actually a grapevine that comes from the home of Phylloxera, which is North America. And there Phylloxera evolved over the last thousands of years, and sort of at the same time the vines developed mechanisms to overcome Phylloxera attack.
Okay.
And that's why we don't actually see any problems there with Phylloxera.
And that's when they brought the grapes over in, the 1860s?
Yeah, sometime mid-19th century. When Phylloxera... Yeah, it was first recorded in 1863, both in France and in England. So we know definitely it was there at that time, but most likely it arrived a lot earlier.
You describe it as an aphid. What does it look like? Is it like aphids? I always think of almost like slaters.
Yeah, most of the stages they don't have wings, so they can only crawl around. But there are also winged forms around. So the normal aphid actually has no wings, and when it hatches from the egg, it actually walks up the shoot, comes to a young leaf, sits on the upper surface of that leaf and starts feeding, and the saliva of that one causes the leaf to develop a gall. So after a few weeks, the animal is sitting completely enclosed by the leaf in a gall.
Surrounded by food, really, isn't it?
Yeah, basically protected against animals. And the only thing it does is actually feeding and laying eggs. And from those eggs, new Phylloxera emerge, hatch, walk up out of the gall, up the shoot, and start the cycle again. So you actually see on a shoot depending on the temperature, every couple of weeks, another generation.
So it's only a couple of weeks, the generation?
Yeah, when it's nice and warm, it's possibly 2, 3, 4 weeks.
But I always thought Phylloxera was a problem with the roots, not the leaves. So I've read about it, and they've talked about almost two life cycles.
Yeah, that's a point. Normally aphids are living on leaves, And scientists believe that because it's very cold in North America, they developed also a life cycle underneath the ground. So Phylloxera also has the ability to feed on roots. And that's where the trouble actually starts, because when they feed on roots of our European varieties like Riesling, like Pinot Noir, not the Phylloxera itself that causes a problem, but Phylloxera creates a gall, which is
just
basically
like
just a swelling. It's not quite as nice as that, but sort of the root swells on, the root gets bigger, and that tissue is very soft. That tissue is not really protected like a root normally is. Yeah. And then after a few weeks, you see fungus growth, possibly also bacteria, growing in that gall. And if the gall goes very deep, the gall will actually go as deep as it gets to the xylem or phloem vessels.
Sorry, the what?
To the water supply.
Oh, okay.
Inside the root.
Yep.
Sap, which is called xylem and phloem. and if that is the case, basically the root will just die off at that point and there will no water transport be possible. So what you see as a symptom of Phylloxera is actually just that the plant gets weaker and weaker and weaker.
Because it's losing roots.
It loses roots, so it sort of suffers from nutrient and water deficiencies.
Oh, okay. So
that's why it also took so long, because the French actually took 5 years before they established that Phylloxera really is a problem of that mysterious disease.
Yeah, because they just saw a load of vineyards dying, didn't they? And they weren't quite sure what was going on.
That's right.
Okay, and then people have said that Phylloxera doesn't survive particularly well in sandy soils. You hear places that have got sandy soils and they're on original rootstocks and there's no problems. Why would that be? Is there any particular soils they like or don't like?
Well, what they like very much is basically nice, fertile, loamy soils. So that's where they really thrive. That is good country for them. If it's getting very wet, they don't like that either. So heavy clay, wet conditions, that's not what they're after. Particularly those fertile soils in most parts, of France, but also in Germany. That's what they really go for.
What about sandy soils, though?
No, they don't like sandy soil.
Why would that be, though?
One reason could be that we don't have so much problems with the fungus growth, which is basically the reason for the plants dying off.
So they're actually in the sandy soils, but then the sand's quite dry, so...
Okay, if there is one there, it won't cause any damage.
Yeah, okay.
So that's possibly both, that they, for whatever reasons, don't really survive.
And if it's clay soils, hard to get through to the roots, would that be a...
Well, with clay, it's just that they don't want water.
Do they need air? Do they drown? Yeah. So if it's quite heavy, there's asphyxiation? Would that be the...
Yeah, I think that is possibly the problem. It's also when it's very wet, it's cold. So that's what they don't really like.
Okay, so we saw these galls on the leaves, and they were quite heavy. In fact, I thought it was quite ugly. Some of them were really, it reminded me of sort of 13-year-old boys covered in zits, really. It was just pocky and horrible.
It looks very horrible, but for the plant, well, actually the extraction of sap for the plant is not really a big problem. So the plant... doesn't really mind. If the plant loses a leaf, that will not kill the plant, and it's possibly the same amount of carbohydrates that disappear. So the suction itself is not the problem.
Okay. You opened one of these galls up, and you showed me the Phylloxera inside. It was just a wee speck of black in there, from what I could work out.
The black one is actually a dead one. Normally Phylloxera is actually yellow. It's quite a light yellow color.
Yeah.
And what you also see there are eggs that are also yellow. So, but the Phylloxera itself is only 0.5 millimeter in size. So with a naked eye, you can, possibly just see it.
Yeah, it was a black speck in there. I saw the black speck. I suppose, do you have the attitude a good Phylloxera is a dead Phylloxera?
Basically, we're fighting Phylloxera with a biological mechanism. So Phylloxera doesn't really matter that much. The thing is, we just don't want to have too much around here.
Yeah.
So we usually spray our rootstocks and our germplasm collection once or twice with an insecticide to get rid of them.
You just kill them on the surface, you can't get them in the ground?
Well, it's actually an insecticide that actually is taken up by the plant. So when they suck the plant sap, That's when they get killed.
Oh, okay.
But that insecticide is not transported downwards. Therefore, it will not kill them on the root.
You said they go down to the roots for winter when it's cold.
Yeah.
Are they down there because it's August here now in Geisenheim, and it's a lovely hot day? Would they be hanging out in the roots there, or
there will always be some on the roots because some stay on the roots all the time.
Okay.
So originally they possibly only went down basically for the winter, but now we have a life cycle that stays in the ground all the time.
Okay, so they're quite adaptive, aren't they?
Yeah, they are.
Matter.
Yeah, right.
Okay, and a lot of your work here, you do a lot of root breeding,
Yeah.
and you said there's two ways of dealing with it. One is to develop resistance to it, and so there was and
The other one is tolerance.
tolerance. Yeah,
So the plant we've seen is tolerant. So we had phylloxera on the leaf, but the plant says, so what? Yeah. Okay, we have other mechanisms where you don't see a goal. In those cases, we have something that we call hypersensitive reaction, which means phylloxera attacks, the plant notices that it has been attacked, and the tissue surrounding that place where phylloxera started to feed just dies off. So what we see on the leaf is just a tiny little brown spot.
okay,
And the same mechanism will also work on the root. So phylloxera tries to feed on the root, and the tissue surrounding that point will just die off. And phylloxera need living tissue. And
what stops them just moving a couple of inches
okay,
away?
it can do that, but sooner or later it will run out of food.
Oh, so it's like it's going. All right, I need a bit of food. Gets to a bit, starts having a go, runs out of food, still a bit hungry. Gets to another bit. Gets a bit hungrier. Eventually, it
That's
just sort of
right.
starves.
So it basically starves to death.
Oh, okay. Yep. Does that mean that if you planted your vineyard with this hypersensitive resistance, effectively you could wipe out phylloxera? Can't phylloxera just go onto apple trees or other vine species?
No, it can't. It can't go onto apple trees or any other herbaceous plant or so. It really relies heavily on grapevines, and so it can only feed on grapevines and nothing else.
Okay. And the tolerance, how does it affect the tolerance? You touched on...
Well, the tolerance is basically just that it's particularly the root that causes a problem. And the root of American species has a different morphology. So we have basically a layer inside the root that prevents those root galls to go deep into the root tissue. So the gall just stays more on the surface. And then a suberin layer, suberin is cork.
Oh, okay.
Yeah, just basically protects it.
It's got cork in it, like an apple.
Yeah, but basically the bark of a cork tree is also suberin.
Okay, all right.
So that's a tissue. The bark is there to protect the
Okay, and that
tree.
means that
That's what we use to put in our bottles.
So, yeah, phylloxera cork. So what you're saying is that the phylloxera is there on the roots of American species. It's just that it doesn't bother it so much.
That's right. And also in America, they have pretty cold winters, so most of the phylloxera get killed during winter. So in spring they start with a pretty low population, slowly go up. Then the next winter comes again, gets the population down again. Okay. While here in Europe, we usually have pretty mild conditions, and that's why we have a lot more problem than they had in America with it.
Oh, okay, that makes sense. All right then, Ernst, I think we'll wrap it up there.
Okay.
Thank you very much. There are a number of things in this interview that we didn't cover that are in the WSD Level 3 course. The key one is that phylloxera, the main way to deal with phylloxera these days is through grafting. That is, using an American rootstock that's resistant to phylloxera and then using like a Vitis vinifera, that may be Pinot Noir or Riesling, and grafting that on. So you get Vitis vinifera fruit, Riesling, Pinot Noir, Chardonnay, whatever you want, and then underground, the rootstock is American rootstock that is resistant to the phylloxera. There are a number of other benefits from grafting, not just phylloxera resistance. These include other resistance to other pests such as nematodes. Nematodes are just like a little worm that lives in the ground that can bother the grapevine. Other things are that you can actually tailor the rootstock to your soils to make them suitable. So, for example, particularly in drought resistance, you might find a rootstock that's particularly good in dealing with drought. Then you can use that in a particular dry area to help the plant survive the real dry periods. Other types of rootstock include rootstocks that are suitable for lime soils or even wet soils. So, rootstocks have a number of advantages, not just phylloxera, they're nematodes, and also providing adaptations to the soils and climate that the grapevine's been grown in particular, drought is the one they used in the WST Level 3 book. One other type of grafting is known as head grafting. This is quite different. In head grafting, you've got an established vineyard that's maybe got an American rootstock and you've then got, say, Chardonnay, but all of a sudden there's an oversupply Chardonnay, or you want to change from Chardonnay to, say, Pinot Gris. The way to do that is, we've got one of two ways to do that. That is either dig up all the vines and replant with Pinot Gris, wait 3 or 4 years for the plant to come into production, and then you've got your Pinot Gris like normal. Or the other option is a head graft, where you come along, you cut off the previous Vitis vinifera, Chardonnay, and then you graft onto it the new vine species that you want to grow. So you could graft onto it, say, the Pinot Gris, in which case, after a year, you'll then have fruit that's Pinot Gris. The advantage of this is twofold. First of all, you get a much quicker changeover from one set of grapes you're growing in your vineyard to another, which is really good from an economic point of view. The second thing is you've actually got an established root system here as well, which means that the plant will be more resilient to droughts or whatever. It's a more established root system, so it can deal with problems going forward.